Double displacement reactions. We're going to look at a lot of these. The way that I know that I have a double displacement, which we also call double replacement, is that the two reactants are both ionic compounds, metal and non-metal, or if it has a polyatomic ion, it's ionic. So two ionic compounds, both of them are dissolved in water. So that's kind of what I can look for. Let's predict products on this. And before I start writing the products, let's look at the charges that are on these ions, because I'll need to look at that as I go. So these ion charges I get by looking on the periodic table from my memorized polyatomic ions, and maybe from my metal ions. Nitrate has a -1. So that tells me silver is +1 if I didn't have that one memorized. Potassium is in the first column of the periodic table. Chloride is in the -1 column with the halogens. Okay, I have my charges. Now what's going to happen is that the positive part of one will go with the negative part of the other. And remember, the positive part is always in front, so the front of one will go with the back of the other. And the charges on these will remain the same. So I look, and that is a good formula. It's neutral overall. And then for my other product, I will have the potassium. Positive one has to go in front, and then my nitrate. And once again, if I look at my charges, for this as well, it comes out neutral. If it didn't, I would have to adjust my subscripts. Okay. The next thing I'm going to do is check and make sure this is balanced, and quickly I can tell you that it is balanced. And next, I am told that the reaction occurs, a precipitate forms. A precipitate is a solid product. A precipitate is a solid product because that compound does not dissolve in water. So do I see one of these that I know will dissolve in water? And the one I know will dissolve in water is the potassium nitrate, because if we know our soluble ions, potassium and nitrate are both on that list, so that is water soluble. So if I have a precipitate forming, it must be this silver chloride. Okay, this type of chemical equation is called molecular. And the reason that it's called molecular is because I'm writing these compounds as though those ions are actually stuck together. But we know an ionic compound that is dissolved in water will actually be ionized. In other words, the two ions will actually be floating around separate from each other. So the next type of chemical equation we're going to write, the complete ionic equation, we're going to show, be more truthful and show them split apart when they really are in real life. So again, what we got to do is look at each one and decide if it's a strong electrolyte, which means it's completely ionized. So use our solubility rules. Is silver nitrate ionized? Well, for one thing, it says AQ, so that I know it will be. But also it has nitrate, so it would always be ionized. So I'm going to split those apart. Because this is how they're really floating around in the water. Next, potassium chloride is same. It is ionized. It dissolves in water. Now the silver chloride, it's a solid, so I don't split it apart. It is actually stuck together in a solid crystal. But any of these ionic compounds that say AQ, or we know they're dissolved in water, then we don't split those apart. Okay, also when I do this, I should be writing state symbols on everything. Notice that when I do this, I write a charge on every ion that is floating around by itself. And I should have state symbols on everything. And it's balanced. Up here, my coefficients were all 1. So it wasn't too hard, but when I split this apart, it should still be balanced. Okay, and do you notice anything that is not changing in this reaction? In other words, are there any ions that are there before the reaction and they're just the same after the reaction? And so what I'm looking at is I see that the nitrate is really not changing. I have nitrate before and after. Same with the potassium, before and after. And so those are our spectator ions. Okay, so when I write my net ionic equation, I'm going to leave those out. I'm going to show what is actually reacting. A chemical reaction involves breaking or forming new bonds and/or forming. Okay, and so that's our net ionic equation. And then a note here. In order for a double replacement reaction to occur, one of the products must be a precipitate, abbreviating PPT for precipitate, or a covalent compound. And remember, we say molecular for covalent as well. And a room there. And just a note that in the reactions we're going to see, often the molecular compound that we see is water. Okay, so we'll see either a precipitate or a covalent compound being formed. And if we don't see one of those, then no chemical reaction is occurring. So for our double displacement reactions, when we write our complete ionic equation, we're going to have to know which compounds we separate into ions. So we are going to look for ionic compounds that are water soluble, say AQ. We're going to know that they're water soluble based on those 6 soluble ions that we've learned. Or we'll separate ions on strong acids and strong bases. So we need to know those as well.